And I'll continue to introduce the next speaker. So we heard about GraphQL, we heard about Storybook, and now it's time for a little good old state management. And I think that's a topic that everyone who worked a little bit with React running into. So our next speaker is Alireza Kasayan from SmartWare. Alireza is going to talk about state management and how it should reflect your app's needs. A little bit about Alireza, a front-end software engineer at SmartWare, focuses on React.js, and mostly likes to talk about BDD, TDD with people about who care about high-quality products. So I hope you find enough people that care about high-quality products. Welcome, Alireza.
Thank you, Liad. I'm happy to be here. It's been a long time. I'm waiting for this event, and I've been busy, but I really did my best to prepare a good presentation for this event.
Yeah, we are looking forward to the talk. Where are you talking from now? Where are you?
I'm in Dublin. Weather is good today. It's look like a good day today. Yeah.
Okay, great. So yeah, without further ado, we can get to the talk.
So yeah. Do you see my screen?
Yes.
Yeah. Okay. So, as Liad said, I'm Alireza, but my friends call me Ali. I'm software engineer at SmartWare. SmartWare is a company that provides tools to streamline development team process. These tools are designed to immediately impact the delivery of applications. I'm a part of Swagger Hub team, while there are other great products like Ready API, Zephyr, Cucumber. I've been using React since it released first days of React, and I'm today going to talk about state management systems in React.js. As a software engineer, when I want to select a state management system for my application, I need to take care of some parameters. These parameters are important because a state management system is the brain of application. Let's quickly understand what is a state and what is a state management system. I know many of you are using state management systems, but it's good to take a look at them. The state is the data object of the application. React has local state and global state. The local state is the data object shared in the application and the component scale, and the global state is the data object shared among all the components in the application. So what is a state management system? A state management system is the brain of application. What does that mean? It means it's like an engine that takes care of the state and controlling state, and also it updates the UI based on user interactions. There are questions that if we answer them, they would help us to understand what is the best state management system in our application, and how we can choose a state management that best fit those applications. When we choose them, when we know what is the best, what is the state, what is the application type, we can say what is the most proper state management system for those applications. And when we know what are those state management systems, we should know what are do's and don'ts of them. So many of developers and software engineers, they go with trendy state management systems because many of people are talking about those state management systems. Some others go with the state management systems that have biggest community, or they are more reliable. they are, or those state management system that the team is experienced with, or they themselves are experienced in those state management systems. But the most important thing to consider is the application itself. This is the most important parameter. And today we are going to talk about this requirement and see what is the proper state management system to answer those requirements. The first state management, the first application type I want to talk about is editor applications. Editor applications are called editor applications because they are holding the data set on the client side, and they are holding the data on the client and modifying them based on user interaction. And they are source of truth. The data on the client side is the source of truth in these applications. Applications like video, image, text, and other content editors, they are editor applications. Let's imagine I want to create a new image or edit an image. I give the image to the application, I add fonts, I change the font, I remove a part of the image. All these changes, I need to be tracked. I need to have access to versions of my of my changes, so I can go back in the history. If I miss something at some point, I can go back and take the correct version and continue editing that. At the end, I will be able to save the data and share it on cloud or save it on my device. So the structure, these are things that user need, and these needs gives us an idea of what is the application requirements. We need to have a data set on the client side. We need to keep track of changes the user makes on this data set. And we need to have components up to date with the changes on the dataset. We have options here like Redux, PoolState, Mobix, and RxJS. These state management systems are great for editor applications because of the structure they are providing us. They give us a global state. They give us actions that triggers reducers and reducers that update the global state. It's a series of actions we take to update state from component to the global state. I want to describe it with the image editor app example. I want to edit this image. I add text, and now I want to change the font. I select the text. I change the font from the menu. Click on dropdown, click on the font, and I need to see the font changed on the editor page and on the menu and anywhere on the app that menu exists. So from the user point of view, it's a series of action. But what happens on backstage? On backstage, we need a structure like a series of actions that happens and global state gets updated. On the component, we get the onChange function called because the font is changed. We need to update the global state. So we call the onFontChange action, which is a function that gets the font value if we have the data prepared on the client side. We have the data ready to update the state. We trigger the user. But if we don't, we call an API or we call other actions from that action to prepare data to update global state. When the data is prepared, we trigger the reducer. Reducer gets the data from and passed from action, the key and value. It has access to the global state at the current state, and it updates the state based on the key and value. It prepares the new state and updates the global state with the new value. When global state is updated, all the components binded to the global state, they get the update, and they would update the UI based on that change. This is a series of actions, a lot of things to care, and we have control on each step. And also we have the ability to change each step and fetch data at each step, or modify the data at each step. It's a lot of power and strength required for editor applications. But there is also another type of application that, from user point of view, it would be editor application, while from software engineering point of view, they are not, because they are saving data on the client side, on the server side, and they are presenting that data from the server. Applications relying on the server side as the source of truth are presentation applications. These applications are presenting data that service providers are providing to the clients on the browser side. Applications like messaging apps, online banking applications, media streaming applications, and applications like them, they are presentation applications. These applications have specific requirements. For example, they need to be in sync with the server to provide valid data to the client, to the user. As a user, I want to use banking application. I open my banking account on different browsers, and I want to see the same value on both of them. I do not expect to see $1 million in one browser and $1 in the other one. I get panic. It's insane. So I really need to have updated value on both browsers. They need to be in sync with the server. Is it possible to implement it with previously defined state management systems? Yes, it is. But it's like a headache. Why? Because server side has a structure, already has a structure like Redux and its alternatives. All those data flew from entry point to the global state, which is database or whatever on the server side. We don't care about that, but we know such a structure is living there. If we implement it on the client side for these applications, it's like we are duplicating it. And also, we need to send a lot of requests to the server to keep the client in sync at each step. We need to go through all those steps of updating global state here to keep the global state in sync with the server side. So what's the solution? What we expect is to just call a function and get the data and present it. React Query, SWR, they give us this power because of the structure they have. HTTP layer to fetch data. They have a caching layer, and also they give us queries to call and get the data from server. Let's go with the streaming applications. We all know Netflix. So Netflix as a streaming application is a presentation application. On the home page, we have a list of movies. When we click on a movie, we get a detailed view. We expect to see details like description, comments, and we are able to watch the movie, like it or dislike it, or add comments. From user point of view, it's the flow, but what happens on the backstage? On Backstage, what we need to do is to trigger the action, clicking on the movie. We get that. We call a query. Queries, this is a React query example. Use query, the key is movie, and we have a function to fetch data. When we call it from the component, we get the data from server, and we now present it to the user. That's simple. But what happens inside the React query? What happens inside React query or its alternatives? They get this function called. They have the key of this query. The library sends the request to the server side. It gets the response, and it updates the caching layer. If the query is used by other queries, or it's used by multiple components, all of them get update. And the component layer, the view layer, gets the update, and it shows the updated values. There's a lot happening inside React query. But when we are developing those components in the UI layer, we do not care about what is happening there. What we care about is that we are just calling a query, and we are getting different stages of the fetching data, and we get the data ready on the components, and we are able to update the layer. When fetching is happened, when cache is updated, boom, all the components get the update. It's simple, it's easy. I love the simplicity they provide us for presentation applications. There is another application type, which is a mixture of presentation applications and editor applications. Applications like social media applications, project management applications, cloud editors, these are mixed applications. Most of us have experienced working with project management applications like Jira or Trello. There is a backlog of tickets. You click on the ticket, you see the ticket view, and also you have the option to add a ticket to the backlog, the presentation part and the editor part. So it's good to know what's the proper structure for these applications. What I would suggest is React query or its alternatives together with React Context. React Context is a built-in functionality. It gives us a context provider that we can wrap components inside it. And these components have access to the context. So this would be the structure for editor part, and the presentation part would be the same as presentation applications. Let's go with an example, which is Swagger Hub. In Swagger Hub, at the first page, we can see a list of APIs. When I click on an API, I move to the API detail page. In the API detail page, I can explore the API itself. I can look for a path or a tag or info of the API documents. And if I have access and permission to edit this API document, I would have this page as editor too. So what is the proper structure for these applications? As I mentioned, a presentation structure, which you can see on the right side of the graph, and the React context, how they communicate to each other. So React context wraps a group of components. When I edit the API, the component updates the context. And all the components connected to that context, they get the API. So I can see the change on different places everywhere that I'm using that context. I edit the API. I'm finished with the editing API. Now I click on the Save button. When I click on Save, the data object from the context passes to the query, React query or its alternative, the library. It passes the data to the server, it gets the response, and it updates the caching layer. When the caching layer gets updated with the coming data, now the same thing happens as it happens in the presentation applications. All the components connected to the query or related queries, they all get the update, and we have the updated view of the application. These application types were based on the client-side application requirements. But if we consider another type of requirement of application, what if we need to fetch data from different service providers? Is it the same? I would add another type, which is multi-source applications. When we want to fetch data from different resources, we need to have a specific structure. Applications like price trackers, car rental apps, or applications like them, these applications are multi-source applications because they mostly gather data from different resources. They call different APIs. They gather data, concatenate them, and present them to the user as a list. For example, for car tracker, for car rental applications, we on the main page, we have a search button. I select the type of car that I want to get a list of those cars. I hit the search button. Now I expect to see the list of cars. Is it possible to implement these type of applications using previously defined state management systems like presentation model applications or editor ones? Yes, it is, but it's not efficient. Why? Because we need to call different API service providers, and we are using a lot of user resources. We are using a lot of network resources. And also, the data we are getting from those API providers, that data is not efficient for us because each service provider is they have their own set of property for car. For example, if we just need color, name, and price of a car, they are sending a lot of redundant information when we call those API calls. So what is the best solution here? The best solution we can have is calling one API call and get exactly the same data object as we need. We have choices like having Apollo server and its alternatives as BFF that I will describe, together with Apollo client or Relay. Because they provide a structure, backend for frontend, that gathers data from different API providers. Apollo server is providing us GraphQL structure. And Apollo client or Relay, they are able to communicate with the GraphQL backend. And they also have the same structure as React query and presentation applications. We also can use this structure with mixed applications that are hitting different resources. The proper structure here, I would suggest, is that a presentation application structure at the bottom of the graph, as you see, or a mixed application structure at the bottom on the browser side with relay or Apollo client, and the server side, which is BFF. To describe BFF, BFF means a Node.js application or a small backend for client side that provides the required data, required data for the client side. You do not need to have a lot of knowledge of backend development. You need to know Node.js and JavaScript, as all Node.js developers know. Apollo server itself is very simple to implement. So implementing that doesn't mean that you are a backend developer. As a front-end developer with a small knowledge of Node.js and learning Apollo server library, you would be able to implement a server for your client side. So what's the benefit of that? Let's go with the current application. I have the query. I know what user is looking for. I send the query from component to the library. The library passes the query to the Apollo server. Apollo server gets the query, sends the requests to different service providers. When it gets the response from the service providers, it makes the data set exactly the same as GraphQL or Apollo client asked for. So if you are looking for color, name, and price, all the car objects would have only those properties. When Apollo server builds that object, it caches the response. It sends the data to the client side. We also have a caching layer on the client side that caches the query, and the rest that happens exactly the same as presentation applications. All the components get updated with the recently received data. There is a lot of benefits around that because you're just sending one request. Even we are caching that request. So if you are repeating a request that we do not need a fresh data for them based on the logic of application, we just send one request for one time and we use the client side cache. If different clients send the same query to the server also has cached the response and it returns the same value to all those client sides. And it means that we are not making too many requests to different API providers. It helps us to have a faster application, use the least network users, and it's very efficient and powerful structure for this type of applications. This was the way I think when I want to design a new application. You can also follow me on the LinkedIn or Twitter. I'm really happy to be here today, and I hope you have enjoyed this presentation. And yeah, that was it. Thank you
so much, Alired. Thank you so much. It was super interesting. Actually, I never thought about it, about choosing a state management according to the type of your app and not just according to the latest buzzword or whatever has the most stars on GitHub. Yeah, that's a really nice way to think about it. I think we have some questions from the audience, and in the meantime, what do you think about using React context as an alternative to Redux?
As I mentioned, React context is for me. I prefer to use React context for a page. I do not go with React context for the whole application because there are, if you use that, you need a lot of performance improvements. because if you update React context and you do not care about the performance of your application that much, or you do not have time to spend on performance of your application, you would use a lot of user resources, or your application would lag, or it won't perform very well. But Redux is a library built for gigantic applications. It's scalable, and people in the community are taking care of those performance issues. They resolve them for you. So it's better to go with Redux or RxJS or Mobex for bigger applications. It's if your application is small, or a small part of your application is using need to have data on the client side and modify that, I would suggest React Context for them.
Okay, great. Gabriel Vianes wants to know if you have any insights on Recoil.js.
Oh yeah, Recoil. I didn't suggest Recoil because Recoil is great. I really love Recoil and its idea. It's I think it's simple. It has the power of Redux. It's simple, but it's experimental. So I do not go to production with experimental libraries. They would stop it at any stage. So it's not reliable in my opinion. I have experience that I have used experimental libraries and they stopped implementing that, and I stuck in a abundant library.
Yeah, so actually this brings me to the next question. What if someone already has a state management system in place? So how do you replace it?
Yeah, so it's a discussion we had in our company. So different approaches there are, and you can take one of them. So the two big approaches that comes to my mind are, first, you can go with features in your application. So you change the data state of your application for a feature, and all the components connect to new state management system, and the rest are using the previous one. So two state management systems live at the same stage of your application at the same time, but after a while you remove the old one and replace it with the new one. There is another approach, which is replacing them at once if your application is big, so it's not a good option. I would suggest another one, which is going based on the API calls. For example, if you are replacing your Redux with React query, all the related API calls to, for example, user endpoints, you go and replace all of them and replace them with React query. That's another approach. So these approaches come to my mind, but myself, I go with the feature-based replacements. So I replace state management for each feature, and I keep them both living for a while, but it's worth it.
Yeah, so maybe a follow-up question for that. When you select a state management system, so you think about the type of your app, like you suggested. How do you make sure that for the state management to have the right abstraction, so that if you need to replace it, or if, for example, your app becomes from presentational to editor at some point, how do you make sure that you have the right abstraction in your app? Or would you just use the state management library or system as is without any abstraction?
Yeah, so I prefer to have abstraction. It's, for example, for React query, they are based on React. They are based on hooks. So hooks are abstracted themselves, but you still can wrap them in the function, and we can call them query. For example, you have Redux. You want to you can abstract all your API calls and those actions that are fetching data. you can call them query, keep them as the query, and actions that are interacting as action, mutating server side, you can keep them there. So we have queries and actions in Redux. So it would be simple if we replace the Redux structure with the React query and keep those queries and actions the same. So as React query is hook, but React Redux is wasn't using hook. I think they are using these days. So I haven't used Redux hooks if they are providing. I think they had the plan to add it. I'm not sure if this is added, but if they have, so they have both structures. But if you're not using Redux hooks, so you're going from the old-fashioned to hooks, and that's a bit challenging, but you're still using the same functions to update the state for queries and mutations.
Okay, thanks. So when you have a need, for example, to update both the client and the server, what would you recommend? Would you recommend to do some sort of an optimistic update, which is to update the client and the UI without waiting for the server's response, and therefore risking, I don't know, some to get out of sync with the server? Or would you recommend to send it to the server and wait for the response? How do you handle that?
It really depends on the application I'm developing. If I'm developing an online banking application, that's dangerous. I never go with updating client side. I never touch that, because if the user loses the connection and they have another connection on another device, and they check, okay, I have this amount of money on this account and the other amount on the other account, that's mad. So I never do that on this type of applications. So basically, most of presentation applications are like this. For mixed applications, I really go with the product team idea, because it's more a product decision than a development team decision. If we want to have cache data on the client side and show that to the user, or we want to be always valid with the server, that's not something that development team take decision over themselves. They need to communicate with the production team and talk to them, make decision there.
And if you're using some sort of a mechanism like WebSockets that also updates all the clients once there's a server change, how do you handle it in the client side, where you have an information that the user put and then you have an update from the server? What do you think? What are the best practices to prepare for such an event, like a collision of some sort?
Yeah, so that's a good question. But we still need to know what is the application type. So if the application is, for example, mixed application, and we are developing something like Google Drive, editing Google documents, we are multiple people working on the same document. Yeah, well, for that part, we need to be in contact with the server using WebSockets. And the editor itself, it's using the structure of Redux or React context. So we are keeping the connection live. Anytime any update happens, we update the context, we have the editor updated. I do not think for usage of WebSocket in presentation applications, but in editor applications, the same happens. So it's mostly about presentation applications, or if it is, for editor applications. If it is presentation application, it would be messaging system that it's another decision to make if you want to keep React query as the state management system for our application, or we want to have change it to a mixed app, because you are still editing the message for the messaging part, that you can use the React context yet and keep it updated with WebSocket. So it really depends on the technologies you choose. But the requirement is, if the requirement based on the technology is WebSocket, so maybe I go with Redux, even if I'm using, if the application is presentation application, because WebSocket itself is keeping me updated with the server. It's always sending data. I do not need to take care of the communication or caching data. It's a live connection, and I just need to update update the local state based on the data coming from server. So any type of editor state management systems, they would work.
Okay, a few questions about another state management libraries. Are you familiar with Jotai and Nextstate for state as a state machine? What do you think about them?
I haven't heard about Jotai, but I've heard about Exastate. I think Exastate is something like Recoil. I'm not sure, but from things I heard, I have never worked with that.
Okay. So when do you think, when do you find React hooks or context is not enough for the app and you need to move to Redux? What do you say would be like the tipping point where you say, okay, now I need a global state management?
React hook. Okay. So I can say this question is like when we need global state or when we need a local state. So local state is for a component a component itself. It's for a component scope. If you have a lot of components in your tree of components, all binded to the parent state, it's very dangerous, because you are sharing the parent state for the components, child components. But at any state change, you're updating the tree, and all these components are getting updated. It's not scalable. If your application is very, very small, that might work, but I would never go with that, because even in those small applications, when user interacts a lot and there are a lot of things to change, when state is continuously updating, it means that you are always rendering all the components and the whole view for each change, and it's not efficient. So I usually go with the component state for small components. On the UI layer, the other components would be connected to the global state, and also those components would be connected to the global state, because when the global state gets the update, it updates it sends the updated data to those UI components, and when they have the updated data, they would update their local state based on the coming data, or present the coming data directly. So always we always have the view updated with the data on the global state.
Okay, thanks. So one last question, maybe. What do you think about cases where you need to also update the URL according to the state? For example, you need the state to be reflected in the URL, the UI state. So do you handle it as a side effect of the state update? How do you make sure that if someone inputs something to the URL, it gets reflected in the state? Which is the source of truth in that case? The URL or the state? Or
let's say React. Sorry. React Router. So let's say React Router is taking control of the URL and history of the browser. React Router itself, it's providing hooks. So we can imagine React Router itself is a state management, because it has the state, it's controlling the state of the browser itself, the URL history, that user interaction with the URL. All of them make impact on the state of React Router. So React hooks, they give us the update from the React Router state. That I would say they are similar to React query, because we have a cache. That is a cache, that is a state on the client side, and we are binding components to that, and anytime it changes, we get the change on the component itself, so we can update the UI based on that. And if we are using another library, that library probably is providing something like React Router, or if it is not, we can wrap that library and create a cache for history of the browser and bind components to that history.
Okay, thank you very much. There are a lot of additional questions, but I remind all of you that Alireza will be back for the Q&A session at the end of this block, where we will be able to chat a little bit more about state management, GraphQL, and everything else. Thank you very much, Alireza.